Hello, Professor and everyone. I'm Guo Haokun. I'm here to finish the radio question in homework 5. So let's get started from the question 1. The question 1 is x and y are independent, and we know the property density function of each of them, and we know the function between the x and y. The question is find the probability density function of they by two methods. The first sub-question in this question is use the convolution method. So the first sub-question we need to use the convolution approach. As we know, the density probability function of x and y, but there is some check in the density function of x. So the first thing we need to do is we can calculate the result from the density probability function of s, use this formula, and the probability density function of y of this formula. And after finish the calculation, we can just move the result to the right by 1, and we can get the whole result of this question. Why? Because when we need to put the parameter of x, the distribution of the question is not easy enough for us to use. So we use the convolution method, and we just use the integration, use the parameter a. After the calculation, we can just use the formula and parameter, put them in the function, and after many calculation, we can get the result of using parameter z as this formula. And also we can draw the image of each part of the result using different color like this. So just as I said before, because we use this formula, and the next thing we need to do is shift this result to right by 1, and we can get the probability density function of the z like this one. So just the last part need to do this this changeable function, and that's the first part of the question. The second question is more easier to understand than the first question, to use geometric method, and that's just to use the definition of the probability distribution function. We can get the result very easily. So when z is smaller than 1, we can draw the function of the z, x, and y like this. And in this situation, we can get the density function of z from the definition of the z like this. And after the differentiation, we can get the density function very easily. But that's just one situation. When z is larger than 1 and smaller than 2, this line will change to this part, and we can also get the distribution function like this. And after the differentiation, we can get the density function like this. After the z is larger than 2, the probability of this situation is 1, and the density is equal to 0. And we just put all this situation together, and we can have this image. So actually, when we calculate at the first method, we put all the image together, we can have the distribution function of the image just like this, and it is just similar as we use the second method like this, and we put all the result in this two part. We can get the result very easily like this. So in this part, we can first get the image, and from the image it is very easy for us to get the two functions of the z. So that's the first question.